Hi everyone. So let's discuss about one of the very important concept related to this NumPy array. So like a views and a copy. So let's first see about what is views and then we'll see about the copy. So for that, let me create one NumPy array. Let's say 2, 5, 0, 10. Now let me create another one, but I'm not going to create a brand new one, but I'm just going to point it to A, like B is equal to A. And let me just execute it. If I just try to print it, both of this A and a B, I have exactly same values like 2, 5, 0, 10, and another one B also having a 2, 5, 0, 10. Let's say if I try to modify one of the element of this A array. So let's say A, 0th element of this A, I'll just make it like a -5. And now just think about that. If I try to print A and B, what are the values will be printed? So let's say A and a B. So A is okay because 2 got replaced by -5, then 5, 0 and a 10. But now you can see here values in this B array also got replaced. Why this happens? Because whenever you try to do this way any kind of assignment, this NumPy library will not create a brand new NumPy array for you. It just create a views of that particular array. So it is something like you are trying to watch the same universe, or you are trying to watch some particular planet with two different telescopes. So now at the first sight we are trying to see the same array with variable A, we are trying to see the same array with variable B. So when we did actual modification on A, it is just the views of A. We haven't done any kind of modification on array A. It is just the views of A, and that views we got to see with the help of another variable like a B also. So that's why the original source data got changed and it got reflected into both of this variable A and a B. Now why this happens? So we can see, or we can verify this thing with the help of memory location. So to know about the memory address where this NumPy array got situated, you can use the id function and find the A. Same way we'll find the memory address of B. So now you can see both of these numbers are same. That means it has not created a brand new NumPy array for us. Instead of that, it has just created a views because of this assignment operator. So whenever you try to do any kind of modification related operation on this particular memory location, eventually both are the same memory location. Let's create another variable, let's say C, and from A we are going to use, or we can use like a view also. So we can just simply do the assignment, or we can use this view method. Okay, let me just execute it. Now if I try to display A, B and C both all together, you can see the values inside that A, B and C are same. Let's say if we do the address, if we find the address of this A, B and C, address is for C is now different. So whenever we try to do the assignment operation, even the address was changed, but in case of view the address is completely different. Now let's try to do some modification into one particular array. So let's say we are trying to change the modification into C. So let's say C2, I'm going to change it to, let's say 200, and let's just display all three one by one. So 1, B and C. Now you can see even if we have changed only in a C variable or a C NumPy array, it got reflected in all three because C has just created a view. Now don't get confused that in this case the memory location is different. Still memory location is different, but that memory location is again pointing to some other memory location, and that is internally going to point the actual data where this -5, 5, 0 and 10 resides. So whenever we try to do any kind of modification on a C variable, eventually it got reflected in a other two variable also, because both of those variable also pointing to same place in a memory. So that is nothing but the views. So in case of views, whenever you try to change in one particular variable, its another view also got reflected all those kinds of change. So first we have seen with the help of assignment operator, but in case of assignment operator, the difference is that the memory location is same. But in case of this view method, the memory location is still different, but all those kinds of modification related operation will be applied on all those views. Okay, so that is all about the views. Now let's see about the copy, that how you can create a brand new NumPy array from another NumPy array. So we have a, let's say, now from this A, I want to create another NumPy array, let's say X. So I can just simply use like a copy. Now this is not like a view, it is like a deep copy. And let's just display A first. So no modification in A. Along with that, let's just display X also. So both of them having the same data. If we try to get the address of this X, first let me get this A and then X. So address of this both of them is completely different, you can see. Now let me do the modification in X. Let's say X0, I'm just going to make it like a -40, and let me display A and X both again. Now you can see change got reflected only in a X but not in a, which indicates that whenever you try to create a brand new object or brand new NumPy array object, in that case it doesn't get reflected into other one, because both of this variable resides on a different physical memory location. Because whenever you try to do any kind of modification at this particular memory location, the change didn't get reflected into other memory location. Okay, so that is what the basic idea behind this copies and a view, that in case of view it is pointing to the same physical memory location, so change will get reflected on every single views. Whereas in case of copy, now how this copy will be useful, so whenever you are trying to do any kind of modification in your original data and you don't want to modify your original data, you want to keep a separate copy of your original data, so in that case you can just create another copy, and all those kinds of operation you can perform on the top of it. Okay, so that is what the basic idea behind the views and a copy in a NumPy object.